Welcome to Tech with Koushik. This is set 5 of our AI-200 Microsoft Certified Azure AI Cloud Developer Associate Practice Question Series. Choose your answer before the timer ends. Then review the correct answer, detailed explanation, and exam tip. Keep track of your score and see how exam ready you are. Each practice set is completely standalone, so you can start here without watching any of the other sets first. Playlist link is in the description. Let us begin set 5. Now tackle question number 159. We are now working with GitHub OIDC Federation. A GitHub Actions deployment workflow must authenticate to Azure without storing a long-lived application secret or certificate in the repository. Which authentication design best meets the requirement? The choices are: Option A, configure a Microsoft intra-federated identity credential that trusts the GitHub OIDC identity and use OIDC-based Azure login. Option B, store a service principal client secret as a repository secret and rotate it manually. Option C, store an administrator password in the workflow. Option D, disable Azure authentication for the deployment job. The correct choice is Option A. Configure a Microsoft intra-federated identity credential that trusts the GitHub OIDC identity and use OIDC-based Azure login. The key clue points here: because Workload Identity Federation lets GitHub issue a short-lived OIDC token that Microsoft Intra ID validates and exchanges for Azure access. No long-lived Azure client secret or certificate has to be stored in GitHub. B. A stored client secret is exactly the long-lived credential the design must avoid. C. A personal administrator password is unsafe and inappropriate for workload identity. D. Azure deployment operations still require authentication and authorization. Watch for this clue in similar questions. GitHub to Azure OIDC Federation removes stored Azure credentials, but does not remove the need for appropriate Azure or BAC. For question number 160, separate the requirement from the distractors. Look for the wording that eliminates the distractors. A security review compares GitHub Actions Workload Identity Federation with authenticating the same deployment workflow by using a service principal client secret. What is the primary security advantage of Federation? Watch for distractors that are valid services, but wrong for this scenario. Next, Option A. The workflow can exchange a short-lived external OIDC token for Azure access without storing a long-lived client secret. Next, Option B. Federation automatically grants owner permissions. Next, Option C. Federation removes the need for Azure or BAC assignments. Next, Option D. Federated workflows can access only non-production resources. The best answer is Option A. The workflow can exchange a short-lived external OIDC token for Azure access without storing a long-lived client secret. Here is the reasoning that confirms the answer. Federation establishes trust in the external workload identity and uses short-lived token exchange, reducing secret leakage, rotation, and expiration risks associated with client secrets. Check why each remaining option is not the best fit. B. Federation does not grant broader permissions automatically. C. Azure or BAC still determines what the identity can do. D. Federated identities can be authorized for production resources when policy permits. Remember this decision rule. Federation changes how the workload proves identity, or BAC still controls authorization after authentication. Move to question number 161. The difficulty is medium. Avoid choosing by keyword alone. Identify the requirement in this scenario. An Azure-hosted service obtains a managed identity access token intended for one downstream API. The application then sends the same token to a different Azure service that validates a different token audience. Why is the second call expected to fail? Review the options. Choice A. Access tokens contain an audience that identifies the intended recipient, so the application needs a token requested for the second target. Choice B. Managed identity access tokens are universally valid for every Azure resource. Choice C. Managed identity tokens never expire. Choice D. Audience validation applies only to user-assigned identities. The required response is Option A. Access tokens contain an audience that identifies the intended recipient, so the application needs a token requested for the second target. The requirement to solution match is Microsoft intra-access tokens include an AUD claim for the intended API or resource. A different service should reject a token whose audience does not match what that service accepts. The incorrect choices are plausible, but unsuitable because B. Managed identity tokens are not universal bearer credentials for unrelated audiences. C. Access tokens have expiration. D. Audience semantics apply regardless of whether the managed identity is system-assigned or user-assigned. Exam strategy. Request access tokens for the target resource or scope expected by the downstream Azure service. Let's break down question number 162. Read the scenario with the target outcome in mind. A document approval orchestration must pause after automated analysis and continue only when an external reviewer approves the document. The workflow should remain durable without repeatedly polling an approval API. Which durable functions pattern best fits the requirement? Review the options and eliminate any clear mismatch. Choice A. Wait for a named external event and resume when a client raises that event. Choice B. Call the approval endpoint every second inside a tight loop. Choice C. Terminate the orchestration and discard its state. Choice D. Durable orchestrations cannot wait for external input. After elimination, select option A. Wait for a named external event and resume when a client raises that event. Durable orchestrations can asynchronously wait for external events such as human approvals or callbacks. The orchestration remains durable while waiting and resumes when the named event is delivered. Now eliminate the distractors. B. Tight polling wastes resources and is unnecessary. C. Termination discards the continuing workflow. D. Waiting for external events is a supported durable orchestration pattern. Use this elimination rule in the exam. Use external events for human-in-the-loop or callback-driven pauses. Use durable timers when the workflow is waiting for time rather than a signal. Question number 163 contains an important exam distinction. This is a medium question, so check each requirement. The key exam clue is contained in this scenario. An application already uses a supported synchronous Azure OpenAI model deployment in one Azure region. The architect wants to add batch processing and assumes the identical model, deployment type, and batch capability are available everywhere that synchronous inference is available. What should the architect do before finalizing the design? Focus on which option satisfies the complete requirement. Now examine choice A. Verify current batch support for the intended model, batch deployment type, and region because availability differs by model and deployment geography. Now examine choice B. Assume batch availability is identical to all synchronous deployment availability. Now examine choice C. Assume batch is supported only in West Europe. Now examine choice D. Ignore deployment type because batch does not use model-specific availability. The option that satisfies the complete requirement is option A. Verify current batch support for the intended model, batch deployment type, and region because availability differs by model and deployment geography. This option satisfies the complete requirement because batch support is published by model and deployment geography, including global batch and data zone batch availability. A synchronous deployment being available does not by itself prove that the same batch combination is supported. Here is how to rule out the alternatives. B. Batch and synchronous availability are not universally identical. C. Batch supports multiple regions and deployment geographies. D. Model and deployment type are part of current availability constraints. A useful exam pattern is this. Treat model, version, deployment type, and region as separate availability checks for Foundry model deployments. Let's analyze question number 164. Start by separating the facts from the requirement. A background AI workflow calls a dependency that becomes intermittently overloaded. Immediate repeated retries increase pressure on the failing service. Which resiliency design best reduces retry amplification while still allowing recovery from transient failures? Now compare the choices one requirement at a time. Option A is use exponential backoff for retries together with a circuit breaker that temporarily stops calls after repeated failures. Option B is retry continuously with no delay. Option C is remove every retry and recovery mechanism. Option D is increase the timeout indefinitely and make no other change. The required response is option A. Use exponential backoff for retries together with a circuit breaker that temporarily stops calls after repeated failures. The decisive reason is backoff spaces transient retries so they do not amplify load. A circuit breaker stops calls to a dependency that is repeatedly failing and later allows controlled recovery attempts. The remaining options fail one or more requirements because b. Immediate retries can worsen overload. c. Removing all retries loses transient fault recovery. d. Longer timeouts do not reduce request pressure on an unhealthy dependency. Use backoff for transient faults and a circuit breaker when continuing to call the failing dependency is itself harmful. Approach question number 165. By checking every constraint, we are moving to durable and model capacity. Pay attention to qualifiers such as least, most, and minimum. A team is reviewing durable functions execution rules and Azure OpenAI consumption behavior. For each statement, select yes if the statement is true. Otherwise, select no. Statement 1. Test this claim. Non-deterministic work, such as direct external input-output, should normally be performed in activity functions rather than directly in durable orchestrator code. Statement 2. Test this claim. A provision model deployment automatically provides unlimited burst capacity above its allocated throughput even when spillover is not configured. Statement 3. Test this claim. Azure OpenAI batch is appropriate for a workload whose primary requirement is sub-second synchronous response latency. The correct judgment for statement 1 is yes. Activity functions can perform input-output and non-deterministic work while orchestrators remain deterministic and replay safe. The correct judgment for statement 2 is no. Fully utilized provision capacity can return throttling responses. Overflow requires an explicit mechanism, such as spillover. The correct judgment for statement 3 is no. Batch is asynchronous and targets delayed high-volume completion. Watch for this clue in similar questions. Keep orchestrators deterministic, treat PTU capacity as bounded, and reserve batch for delay-tolerant workloads. Question number 166. Scenario. A durable functions workflow must invoke independent analysis activities for many files at the same time. Wait until all activities finish, aggregate their outputs, and then run a final publishing step. Which orchestration pattern implements this behavior? Compare the options. Option A, fan-out/fan-in. Option B, pure sequential chaining only. Option C, wait for external event. Option D, eternal orchestration. The correct choice is option A, fan-out/fan-in. The key clue points here because fan-out schedules independent activities concurrently. Fan-in waits for the parallel work to finish and aggregates the results before continuing with later workflow steps. B. Sequential chaining does not execute the independent activities concurrently. C. External events are for waiting on outside signals. D. Eternal orchestration addresses indefinite execution and history growth, not parallel aggregation. Remember this decision rule. Use fan-out/fan-in when independent work can run in parallel, but a later step depends on all results. Question number 167. Tests careful elimination. Identify the decisive constraint before considering the options. An application pod in AKS uses Microsoft Intra-Workload ID. A Kubernetes service account is federated with an Azure identity, so the pod can access an Azure service without mounting an application secret. What replaces the traditional client secret credential inside the pod? Compare the options by fit, not by familiarity. Consider option A. A projected Kubernetes service account token that is exchanged through the federated trust for a Microsoft intra-access token. Consider option B. The AKS cluster administrator password. Consider option C. A permanently mounted service principal client secret. Consider option D. Anonymous access to the Azure service. The best answer is option A. A projected Kubernetes service account token that is exchanged through the federated trust for a Microsoft intra-access token. Here is the reasoning that confirms the answer. AKS workload identity uses OIDC federation between a Kubernetes service account and a Microsoft intra-identity. The workload uses the projected service account token for token exchange instead of storing a client secret in the pod. Check why each remaining option is not the best fit. B. Cluster administrator credentials are not workload identity. C. Federation is specifically intended to avoid stored application secrets. D. The Azure resource still requires authenticated and authorized access. Exam strategy. AKS workload identity federates a Kubernetes service account identity to intra. Authorize the resulting Azure identity with least privileged or BAC. Question number 168. Find the decisive clue before choosing. Identify the decisive constraint before considering the options. A durable functions monitoring workflow must continue indefinitely, but its orchestration history should not grow without bound. Which pattern is intended for this requirement? Eliminate every option that violates even one requirement. Next, option A. Use an eternal orchestration that periodically calls continue as new to reset history while keeping the logical workflow running. Next, option B. Keep one orchestration loop running forever without resetting history. Next, option C. Disable durable history persistence. Next, option D. Force the orchestration to fail after each iteration. After elimination, select option A. Use an eternal orchestration that periodically calls continue as new to reset history while keeping the logical workflow running. The requirement to solution match is the eternal orchestration pattern supports workflows that run indefinitely. Continue as new starts a new orchestration generation with reset history, preventing unbounded history growth. The incorrect choices are plausible, but unsuitable because B. An infinite orchestration loop can accumulate excessive history. C. Durable history is fundamental to orchestration reliability. D. Failure is not the mechanism for long-running periodic continuation. Use this elimination rule in the exam. Use continue as new for indefinite durable loops that must keep orchestration history bounded. Focus on the key wording in question number 169. This scenario tests whether you recognize the controlling constraint. A .NET in-process durable functions orchestrator needs the current orchestration time in a way that remains deterministic during replay. Complete the statement by selecting the correct API. Statement 1. Identify the clue in. Read the replay safe current orchestration time from the blank. Choose the stronger fit from 1. Datetime.utc context.current GUID.new or a direct NTP request. After elimination, statement 1 uses context.current datetime. Direct system time AP is, and external time calls can return different values during replay. A useful exam pattern is this. The exact replay safe time API depends on the durable functions programming model. Use the orchestration context rather than system time. For question number 170, separate the requirement from the distractors. This question moves us into GitHub OIDC permissions. Look for the wording that eliminates the distractors. A GitHub Actions workflow uses Azure/login at v2 with Microsoft intra-workload identity federation and does not provide a client secret. Complete the workflow permission required to request a GitHub OIDC token. For the first statement, evaluate. Set the workflow permission ID token to the blank. The candidates are 1. None, write, or read. Complete statement 1 with write. The write permission authorizes the workflow to request the OIDC token. It does not itself grant Azure resource permissions. For GitHub OIDC login ID token, write enables token issuance. Microsoft intra-federation and Azure RBAC complete the authentication and authorization path. Question number 171 is a good test of exam judgment. Focus on the requirement that drives the design choice. A large, delay-tolerant classification workload runs through Azure OpenAI Batch. Most requests complete successfully, but a small subset returns errors. Which recovery approach minimizes repeated processing? The exam distinction is hidden in these choices. Option A. Inspect the batch output and error information, identify failed requests, and submit only the failed work again. Option B. Reprocess every successful and failed request from the original batch automatically. Option C. Ignore all failed items permanently. Option D. Replace batch with synchronous calls solely because some batch items can fail. The option that satisfies the complete requirement is option A. Inspect the batch output and error information, identify failed requests, and submit only the failed work again. Batch results distinguish successfully executed requests from request errors. Tracking request identifiers lets the application build a smaller retry batch containing only failed or unprocessed work. Now eliminate the distractors. B. Reprocessing successes waste cost and compute. C. Failed items still require operational handling. D. Partial batch failures do not inherently require abandoning batch. Watch for this clue in similar questions. Give each batch request a stable identifier so failed requests can be isolated and resubmitted without repeating successful work. Approach question number 172 by checking every constraint. This is a hard question, so test every option against every constraint. Pay attention to qualifiers such as least, most, and minimum. A GitHub Actions deployment works in one repository, but authentication fails after the workflow is copied into a different repository. The Microsoft intra-federated identity credential still trusts only the identity claims associated with the original repository. What is the most likely federation-specific cause? Eliminate every option that violates even one requirement. Consider option A. The OIDC token from the new repository no longer matches the trusted repository identity claims, so the federated credential must be configured for the new repository identity. Consider option B. Federated credentials are automatically cloned whenever a workflow file is copied. Consider option C. Repository identity is never considered during GitHub OIDC federation. Consider option D. A federation mismatch always indicates an Azure network outage. The best answer is option A. The OIDC token from the new repository no longer matches the trusted repository identity claims, so the federated credential must be configured for the new repository identity. This option satisfies the complete requirement because Microsoft intra-federated credentials authorize an external token only when configured issuer, audience, subject, and applicable repository identity claims match. Moving the workflow to a different repository changes the workload identity that must be trusted. Here is how to rule out the alternatives. B. Copying workflow YAML does not clone the intra-trust configuration. C. Repository identity is a core GitHub federation boundary. D. A token claim mismatch is an authentication configuration issue, not necessarily networking. Remember this decision rule. Federated identity credentials bind trust to token claims. Repository, branch, environment, and current immutable repository identifiers can affect the match. Question number 173. Find the decisive clue before choosing. Background. Tailspin processes a large archive of scanned contracts each night. Current environment. The workload sends model requests for extraction and summarization. Results are needed only by the next business morning. Business requirements. Processing cost should be minimized. Technical requirements. The workflow can tolerate asynchronous completion instead of interactive latency. Which model processing mode best satisfies the requirement? Watch for distractors that are valid services, but wrong for this scenario. Consider option A, Azure OpenAI batch. Consider option B, a provisioned deployment size for the maximum possible burst solely to process the overnight archive. Consider option C, synchronous standard calls only, even though immediate responses are unnecessary. Consider option D, a permanently idle provisioned deployment running all day. The required response is option A, Azure OpenAI batch. The decisive reason is the workload is large, cost-sensitive, and delay-tolerant. Batch is designed for asynchronous high-volume model processing with a target completion window around 24 hours and lower pricing than comparable global standard traffic. The remaining options fail one or more requirements because B, peak size provision capacity is unnecessary for a delay-tolerant batch workload. C, synchronous calls prioritize immediate response behavior the workload does not need. D. Keeping provision capacity idle all day conflicts with the cost requirement. Exam strategy. Use batch when work is high volume and asynchronous. Use standard or provision deployments when real-time serving requirements dominate. Question number 174. Tests careful elimination. Background. Tailspin processes scanned contracts through a multi-step Azure Functions workflow. Current environment. Each contract passes through sequential and parallel processing activities. A host process can restart while a workflow is in progress. Business requirements. Completed workflow steps should not be lost after a host restart. Technical requirements. The coordination layer must persist execution history and reconstruct orchestration state during replay. Which capability best satisfies the requirement? Compare the options by fit, not by familiarity. Next, option A, durable functions orchestration. Next, option B, a plain Azure function that stores all workflow state only in process memory. Next, option C, one synchronous script with no durable state. Next, option D, restart the complete nightly workload manually after every host failure. The correct choice is option A, durable functions orchestration. The key clue points here because durable orchestration persists execution history and reconstructs local orchestration state by replay. Completed activity results are recorded in history, allowing workflow coordination to survive host restarts without simply rerunning the entire process from scratch. B, process memory is lost when the host restarts. C, a synchronous script without durable state cannot resume reliably. D, manual full restart discards the durability requirement. Use this elimination rule in the exam. Durable functions separates durable orchestration state from transient function host process lifetime. Next is question number 175. Background. Tailspin deploys its document processing application by using GitHub Actions. Current environment. The deployment workflow requires Azure permissions. Business requirements. No long-lived Azure client secret or certificate may be stored in GitHub. Technical requirements. Microsoft Intra ID should trust the workflow's GitHub-issued OIDC identity. Which authentication approach satisfies the requirement? Choice A, workload identity federation with a Microsoft Intra federated identity credential. Choice B, a service principal client secret stored in a repository variable. Choice C, a developer's personal Azure password stored in workflow YAML. Choice D, anonymous deployment access. After elimination, select option A, workload identity federation with a Microsoft Intra federated identity credential. Here is the reasoning that confirms the answer. Federation lets GitHub Actions authenticate by exchanging a short-lived GitHub OIDC identity for Microsoft Intra access without storing a long-lived Azure application secret or certificate. Check why each remaining option is not the best fit. B, a client secret violates the explicit credential storage requirement. C, a personal password is inappropriate for automated workload authentication. D, deployment operations still require Azure authentication. A useful exam pattern is this. Use OIDC federation for secretless CICD authentication. Then grant the federated Azure identity only the RBAC permissions the deployment requires. Work through question number 176. Step by step. The focus now shifts to selective retry tracking. Background. Tailspin processes thousands of contracts in a nightly durable workflow. Current environment. Most contracts complete successfully. A small number fail during extraction. Business requirements. Successfully processed contracts must not be unnecessarily submitted again. Technical requirements. The workflow must retain enough per contract outcome state to identify only failed items. Which design best satisfies the requirement? Use the scenario constraints to assess these choices. Choice A, persist or derive per contract processing status and resubmit only the contracts whose prior processing failed. Choice B, restart the complete nightly workload whenever one contract fails. Choice C, ignore failed contracts permanently. Choice D, disable extraction for all remaining contracts. The option that satisfies the complete requirement is option A. Persist or derive per contract processing status and resubmit only the contracts whose prior processing failed. The requirement to solution match is per item outcome tracking lets the workflow distinguish successful work from failed work. Retry logic can then target only failed contracts instead of repeating costly processing for completed items. The incorrect choices are plausible, but unsuitable because B. Full batch restart unnecessarily repeats successful work. C. Ignoring failures violates completion requirements. D. Disabling extraction for all items blocks unrelated work. Use stable item identifiers and durable per item status when large workflows need selective retry rather than whole batch replay. For question number 177, separate the requirement from the distractors. Look for the wording that eliminates the distractors. A release workflow in GitHub Actions must authenticate to Azure without storing a client secret. Trust should be restricted to the intended repository identity and the production branch. What should be configured on the Microsoft Intra application? Watch for distractors that are valid services but wrong for this scenario. Consider option A, a federated identity credential that validates the GitHub OIDC issuer, expected audience, and repository/branch identity claims. Consider option B, a client secret with a longer expiration period. Consider option C, a certificate copied to every self-hosted runner. Consider option D, an application configuration that disables authentication checks. The correct choice is option A, a federated identity credential that validates the GitHub OIDC issuer, expected audience, and repository/branch identity claims. Microsoft Intra Workload Identity Federation trusts an external GitHub OIDC identity by matching configured token claims. This lets the workflow exchange a short-lived GitHub token for Azure access without storing a client secret. Now eliminate the distractors. B, a longer-lived secret preserves the credential management risk. C, distributing certificates still creates long-lived credentials to protect and rotate. D, removing authentication is not a valid deployment design. Watch for this clue in similar questions. Federation removes stored Azure credentials. Scope the trust to the intended GitHub workload identity and keep Azure RBAC least privileged. Approach question number 178 by checking every constraint. Treat this as a medium item and eliminate carefully. Pay attention to qualifiers such as least, most, and minimum. An Azure-hosted service obtains a managed identity access token for Azure Key Vault. The service then sends the same token when calling Azure Cosmos DB, which expects a different token audience. What is the most likely reason the Cosmos DB call is rejected? Eliminate every option that violates even one requirement. Next, option A. The token was issued for the Key Vault audience, so the application must request a token for the Cosmos DB target. Next, option B. Managed identity access tokens are valid for every Azure resource. Next, option C. Cosmos DB cannot authenticate Microsoft Intra identities. Next, option D. Recreating the managed identity automatically makes the Key Vault token valid for Cosmos DB. The best answer is option A. The token was issued for the Key Vault audience, so the application must request a token for the Cosmos DB target. This option satisfies the complete requirement because an access token contains an audience identifying the API for which it was issued. A token requested for Key Vault does not become a valid Cosmos DB token merely because the same managed identity owns it. Here is how to rule out the alternatives. B. Managed identity tokens are not universal across unrelated audiences. C. Cosmos DB supports Microsoft Intra authentication in supported APIs and SDK scenarios. D. Recreating the identity does not change the audience encoded in an already requested token. Remember this decision rule. Request a token for the scope or resource expected by the target Azure service. Question number 179. Tests careful elimination. Identify the decisive constraint before considering the options. A model deployment uses content filters for hate, sexual, violence, and self-harm content. Applying the same severity threshold to every category causes unnecessary blocking in one category, while another category needs stricter filtering. Which configuration change best addresses the requirement? Compare the options by fit, not by familiarity. Next, option A. Configure the severity threshold independently for the affected content harm categories. Next, option B. Disable every content filter for the deployment. Next, option C. Increase the model temperature. Next, option D. Use one mandatory global threshold because category-specific thresholds are unsupported. The required response is option A. Configure the severity threshold independently for the affected content harm categories. The decisive reason is Foundry content filter configurations allow the violence, hate, sexual, and self-harm categories to have configurable severity thresholds. The team can tune categories independently instead of applying one blanket level. The remaining options fail one or more requirements because B. Disabling all protection is broader than the requirement and can require additional approval depending on the configuration. C. Temperature controls generation variability, not moderation thresholds. D. Category-specific threshold configuration is supported. Exam strategy. Tune harm category thresholds independently. Do not use model generation parameters as substitutes for content safety policy. Question number 180. Find the decisive clue before choosing. Next, we enter the topic of private DNS resolution. Pay attention to qualifiers such as least, most, and minimum. A private endpoint has been created for an Azure OpenAI resource. A virtual machine in the connected virtual network still resolves the resource hostname to a public address instead of the private endpoint address. Which configuration should be checked first? Compare the options by fit, not by familiarity. Consider option A, private DNS zone integration and virtual network linkage for the Azure OpenAI private endpoint. Consider option B, the managed identity assigned to the virtual machine. Consider option C, the model deployment temperature setting. Consider option D, the key vault authorization model. The option that satisfies the complete requirement is option A, private DNS zone integration and virtual network linkage for the Azure OpenAI private endpoint. The key clue points here because a private endpoint provides a private IP, but clients must resolve the service hostname to that private address. Azure Private DNS Integration or equivalent custom DNS forwarding supplies the required name resolution. B. Managed Identity Effects Authentication, not DNS resolution. C. Model temperature is unrelated to networking. D. Key vault authorization does not control the Azure OpenAI hostname. Use this elimination rule in the exam. Private link requires both the private endpoint and correct DNS resolution from the client network. Approach question number 181 by checking every constraint. Identify the decisive constraint before considering the options. A diagnostic setting sends only an audit log category from an Azure resource to log analytics. During an incident, engineers expect to find a different operational log category that was never enabled in the diagnostic setting. Why is that telemetry missing from the workspace? Eliminate every option that violates even one requirement. Next, option A. Diagnostic settings export only the selected log categories or category groups. Next, option B. Diagnostic settings automatically export every available category. Next, option C. A log analytics workspace can receive only one category per resource. Next, option D. Additional categories require deleting and recreating the Azure resource. After elimination, select option A. Diagnostic settings export only the selected log categories or category groups. Here is the reasoning that confirms the answer. Azure Monitor diagnostic settings explicitly select which resource log categories or category groups are routed to a destination. A category that is not enabled is not exported through that setting. Check why each remaining option is not the best fit. B. Diagnostic settings do not automatically select every available category. C. A workspace can receive multiple log categories. D. Diagnostic settings can be edited without recreating the monitored resource. A useful exam pattern is this. When expected logs are missing, verify both the resources available categories and the categories enabled in the diagnostic setting. Start by identifying the requirement in question number 182. First, locate the key operational constraint. An API latency metric follows a predictable daily pattern. A single static latency threshold produces alerts during normal busy periods and misses unusual behavior during quieter periods. Which Azure Monitor capability is better suited to this signal? Check each option against the exact requirement. Option A is a metric alert that uses a dynamic threshold learned from the metric's historical behavior. Option B is an activity log alert for resource management operations. Option C is a resource lock. Option D is a permanently fixed threshold because Azure Monitor cannot learn seasonal patterns. After elimination, select option A, a metric alert that uses a dynamic threshold learned from the metric's historical behavior. The requirement to solution match is Azure Monitor dynamic thresholds learn historical metric behavior, including recurring patterns, and calculate adaptive boundaries for anomaly detection rather than relying on one fixed value. The incorrect choices are plausible, but unsuitable because B. Activity log alerts monitor control plane events, not seasonal latency behavior. C. Resource locks protect resources from modification or deletion. D. Azure Monitor supports dynamic thresholds for many metrics. Use dynamic thresholds when the normal metric baseline changes predictably over time and a fixed threshold creates noise. Question number 183. An app service application resolves a secret through a key vault reference by using its system-assigned managed identity. An administrator disables that identity and later enables a new system-assigned identity for the app. The key vault reference then fails authorization. What is the most likely cause? Compare. Option A. The new managed identity has a different principal and must be granted the required key vault secret permission. Option B. Key vault references permanently retain access after an identity is replaced. Option C. Key vault automatically transfers RBAC role assignments from the deleted identity to the new identity. Option D. Replacing a managed identity forces every key vault secret to expire. The correct choice is option A. The new managed identity has a different principal and must be granted the required key vault secret permission. A system-assigned managed identity is tied to the resource instance. Removing and recreating it produces a new identity principal. Key vault RBAC assignments or access policies that reference the old principal do not automatically authorize the new one. Now eliminate the distractors. B. Key vault authorization depends on the active identity and its permissions. C. Azure does not transfer the deleted principal's role assignments to a new principal automatically. D. Identity replacement does not expire stored secrets. Watch for this clue in similar questions. After recreating a system-assigned identity, review every downstream permission that referenced the old principal ID. Question number 184. Tests careful elimination. Look for the wording that eliminates the distractors. A standard Microsoft intra-federated identity credential trusts a GitHub Actions workflow for a specific repository identity on the main branch. The same workflow is started from a release branch and token exchange fails. What is the most likely federation-specific cause? Watch for distractors that are valid services but wrong for this scenario. Consider option A. The OIDC claims presented by the release branch workflow do not match the branch-specific federated trust. Consider option B. GitHub branch information can never participate in federated identity matching. Consider option C. Federated credentials automatically trust every branch in a repository. Consider option D. Branch-specific authentication failures always indicate a virtual network outage. The best answer is option A. The OIDC claims presented by the release branch workflow do not match the branch-specific federated trust. This option satisfies the complete requirement because a standard GitHub federated identity credential matches the configured workload identity claims. A trust scoped to one branch does not automatically match a token representing another branch. Here is how to rule out the alternatives. B. GitHub OIDC subjects can include branch or other entity information. C. Standard exact match federation does not implicitly trust every branch. D. A claim mismatch is an authentication configuration problem, not necessarily networking. Remember this decision rule. A copied workflow still needs a federated trust whose expected claims match the repository, branch, environment, or other workload identity that actually issues the token. Now tackle question number 185. We are moving to telemetry data protection. Review the scenario. An application exports full user prompts and model responses to application insights. The telemetry includes customer names, account details, and other personal information that is not required for troubleshooting. What is the primary monitoring and compliance risk? Review the options. Choice A. Sensitive application data is retained in telemetry, increasing exposure and potentially violating data handling requirements. Choice B. Application insights automatically removes all personal information before ingestion. Choice C. Telemetry data is exempt from organizational retention and privacy policies. Choice D. Sensitive telemetry matters only when the application runs outside Azure. The required response is option A. Sensitive application data is retained in telemetry, increasing exposure and potentially violating data handling requirements. The decisive reason is telemetry is stored data. Logging unnecessary personal or secret information expands the locations where that data is retained and increases privacy, compliance, and incident response exposure. The remaining options fail one or more requirements because B. Application Insights does not guarantee automatic removal of all application-specific personal data. C. Telemetry remains subject to applicable organizational and regulatory handling requirements. D. Data protection obligations are not limited to applications outside Azure. Exam strategy. Instrument the fields needed for diagnosis and redact or omit secrets and personal data before telemetry export. Question number 186. Identify the requirement in this scenario. Two engineering teams administer the same Azure resource. Team A needs only limited read operations, while Team B requires broader management operations. An administrator proposes assigning owner to both teams. Which security principle does that proposal violate most directly? The choices are: Option A, least privilege. Option B, geographic redundancy. Option C, data residency. Option D, network address translation. The option that satisfies the complete requirement is option A, least privilege. The key clue points here because least privilege means granting each identity only the permissions required for its work. Assigning owner to a team that needs read-only access gives unnecessary management permissions. B. Geographic redundancy concerns availability across locations. C. Data residency concerns where data is stored or processed. D. Network address translation is unrelated to authorization scope. Use this elimination rule in the exam. Evaluate both role capability and assignment scope. Do not grant a broader Azure role merely for administrative convenience. For question number 187, separate the requirement from the distractors. The focus now shifts to Azure Identity Token Cache. Look for the wording that eliminates the distractors. A .NET application reuses an Azure Identity credential with Azure SDK clients. A developer worries that the token cache can continue supplying an expired access token indefinitely. What behavior should the developer expect from the supported Azure Identity and Azure Core token handling path? Eliminate every option that violates even one requirement. Consider option A. Cache tokens are refreshed according to their refresh and expiry information rather than being reused forever. Consider option B. The first token acquired by the credential is cached permanently. Consider option C. Access tokens obtained by managed identity never expire. Consider option D. Token caching works only for user-assigned managed identities. The best answer is option A. Cache tokens are refreshed according to their refresh and expiry information rather than being reused forever. Here is the reasoning that confirms the answer. Supported Azure Identity and Azure Core client paths reuse credential instances and token caches for efficiency. Azure SDK clients use refresh information to obtain new tokens when needed instead of using an expired token indefinitely. Check why each remaining option is not the best fit. B. Access token lifetime is finite. C. Managed identity access tokens expire. D. Token lifetime and refresh behavior is not limited to user-assigned identities. A useful exam pattern is this. Reuse Azure credential and client instances. Let supported SDK authentication policies manage normal token refresh instead of recreating credentials for every request. Move to question number 188. Review the scenario. A provisioned Azure OpenAI deployment experiences month-end load spikes and returns HTTP 429 when provision capacity reaches saturation. The operations team wants warning before utilization reaches 100%. Which monitoring configuration best satisfies the requirement? Compare the options. Choice A. Create an Azure Monitor metric alert on provision managed utilization v2 with a threshold below saturation and attach an action group. Choice B. Wait for HTTP 429 responses and use no proactive signal. Choice C. Add a resource lock to the model resource. Choice D. Disable monitoring during high traffic periods. After elimination, select option A. Create an Azure Monitor metric alert on provision managed utilization v2 with a threshold below saturation and attach an action group. The requirement to solution match is provision managed utilization v2 measures provision deployment utilization. Because throttling can occur at full utilization, an alert below 100% provides headroom for operational response before saturation. The incorrect choices are plausible, but unsuitable because B. Waiting for 429 responses is reactive rather than proactive. C. Resource locks do not monitor model capacity. D. Disabling monitoring removes the required early warning signal. For provision model capacity, monitor the current utilization metric and alert before the throttling boundary. Question number 189. Find the decisive clue before choosing. Next, we enter the topic of federated identity security. Identify the decisive constraint before considering the options. A GitHub Actions runner is compromised during one deployment job. The pipeline authenticates to Azure through workload identity federation rather than a stored service principal secret. Why does federation reduce the credential exfiltration risk of this incident? Watch for distractors that are valid services, but wrong for this scenario. Next, option A. There is no long-lived Azure client secret in the pipeline to steal and reuse later, although short-lived tokens obtained during the compromised run can still be abused within their permissions. Next, option B. Federation makes the workflow impossible to compromise. Next, option C. Federation stores the same long-lived secret under a different name. Next, option D. Federation automatically grants no Azure permissions to the workflow. The correct choice is option A. There is no long-lived Azure client secret in the pipeline to steal and reuse later, although short-lived tokens obtained during the compromised run can still be abused within their permissions. Federation removes the persistent credential that could otherwise be exfiltrated for later reuse. It reduces that credential theft blast radius, but does not make a compromised workflow harmless. Now eliminate the distractors. B. Federation does not prevent workflow or runner compromise. C. Federation replaces stored secrets with token exchange. D. Azure RBAC still grants permissions to the federated Azure identity. Watch for this clue in similar questions. Secretless authentication reduces persistent credential risk. Least privileged RBAC still limits what a compromised federated workload can do. Question number 190. Tests careful elimination. Pay attention to qualifiers such as least, most, and minimum. A platform team is reviewing access token targeting, private link DNS behavior, and Azure Monitor diagnostic settings. For each statement, select yes if the statement is true. Otherwise, select no. For the first statement, verify. An access token requested for one Azure resource audience is not automatically valid for an unrelated resource that expects a different audience. For the second statement, verify. Creating a private endpoint guarantees that every client automatically resolves the service hostname to the private IP without any DNS configuration. For the third statement, verify. A diagnostic setting exports the log categories or category groups that are enabled in that setting. For the first statement, choose yes. The downstream API validates the audience for which the token was issued. For the second statement, choose no. Clients need private DNS integration or equivalent DNS configuration to resolve the service name to the private endpoint address. For the third statement, choose yes. Diagnostic settings explicitly select which resource log categories are sent to each configured destination. Remember this decision rule. Authentication, private networking, and telemetry export are separate control layers. Verify each independently during troubleshooting. Question number 191. Find the decisive clue before choosing. This question moves us into alert trend detection. Pay attention to qualifiers such as least, most, and minimum. An API's error metric occasionally has a 1-minute spike, but the operations team cares about sustained abnormal increases relative to the service's normal historical pattern. Which alert design is more appropriate than reacting to one isolated point? Compare the options by fit, not by familiarity. Consider option A. Use an Azure Monitor metric alert with an aggregation window and dynamic threshold, and require an appropriate number of violations before firing. Consider option B. Alert on every individual error with no aggregation. Consider option C. Configure an action group without an alert rule. Consider option D. Use a resource lock to detect error trends. The option that satisfies the complete requirement is option A. Use an Azure Monitor metric alert with an aggregation window and dynamic threshold, and require an appropriate number of violations before firing. This option satisfies the complete requirement because aggregation reduces sensitivity to isolated points, while dynamic thresholds compare the signal with its learned historical pattern. Requiring multiple violations can further suppress transient spikes. Here is how to rule out the alternatives. B. Alerting on every error maximizes noise. C. An action group defines actions, but does not evaluate a monitoring condition. D. Resource locks do not analyze metrics. Exam strategy. Tune alert window, evaluation frequency, dynamic threshold sensitivity, and violation count to distinguish sustained anomalies from brief spikes. Approach question number 192. By checking every constraint, look for the wording that eliminates the distractors. A medical support application blocks a legitimate clinical message because its self-harm classification reaches the currently configured threshold. The organization does not want to weaken hate, sexual, or violence filtering. What is the most targeted supported adjustment? Watch for distractors that are valid services but wrong for this scenario. Next, option A. Review and adjust the self-harm severity threshold for the relevant filter configuration while leaving the other categories unchanged. Next, option B. Turn off every content safety control for all deployments. Next, option C. Increase the model's maximum token count. Next, option D. Change model versions without reviewing the filter configuration. The required response is option A. Review and adjust the self-harm severity threshold for the relevant filter configuration while leaving the other categories unchanged. The decisive reason is content harm categories have separately configurable thresholds. Adjusting only the self-harm threshold targets the observed false positive without weakening unrelated categories. The remaining options fail one or more requirements because B. Disabling all controls is unnecessarily broad and can require additional approval. C. Token limits do not control content filter severity. D. Changing the model does not directly correct the filter threshold that caused the block. Use this elimination rule in the exam. Troubleshoot the category and severity that caused a block, then change only the supported filter setting required by the application risk model. For question number 193, separate the requirement from the distractors. This question moves us into federated stage isolation. Identify the decisive constraint before considering the options. A GitHub Actions pipeline has a preview stage that needs read-only Azure permissions and a deployment stage that needs write permissions. The organization wants a compromise of the preview stage to expose only the preview permissions. Which design provides the clearest least privilege boundary? Compare the options by fit, not by familiarity. Next, option A. Use separate Azure workload identities for the two stages, each with its own federated trust and only the RBAC roles required by that stage. Next, option B. Use two federated credentials on the same Azure identity and assume each credential receives different RBAC permissions automatically. Next, option C. Grant one shared identity owner at subscription scope. Next, option D. Remove RBAC and rely only on network restrictions. After elimination, select option A. Use separate Azure workload identities for the two stages, each with its own federated trust and only the RBAC roles required by that stage. The key clue points here because RBAC permissions are assigned to the Azure principal, not independently to each federated credential on the same principal. Separate principals provide distinct permission boundaries for preview and deployment stages. B. Multiple federated credentials on one principal share that principal's Azure RBAC assignments. C. Owner grants far more permissions than required. D. Network controls do not replace authorization. A useful exam pattern is this. When pipeline stages require different Azure privileges, isolate them with separate principals, not merely separate federated credentials on one principal. Let's break down question number 194. Review the scenario and identify what must be achieved. A managed identity was recently granted a different Azure RBAC role for a target resource. Requests made immediately after the change intermittently continue to reflect the previous authorization state. Which characteristics should the team consider while troubleshooting? Use the scenario constraints to assess these choices. Option A is role assignment and identity authorization changes can require propagation and cache refresh time before all requests reflect the new permissions. Option B is every Azure RBAC update is guaranteed to become effective everywhere instantaneously. Option C is role changes affect only resources created after the assignment. Option D is a recent role change can never be related to temporary authorization failures. The best answer is option A. Role assignment and identity authorization changes can require propagation and cache refresh time before all requests reflect the new permissions. Here is the reasoning that confirms the answer. Azure authorization systems use distributed caches and tokens. A recent role or membership change can therefore take time to appear consistently, making short-lived post-change authorization failures possible. Check why each remaining option is not the best fit. B. Immediate global propagation is not guaranteed. C. Role assignments can affect existing resources within their scope. D. Recent authorization changes are a valid troubleshooting clue. After an RBAC change, verify the assignment and scope first, then account for propagation and token cache effects before assuming the role definition is wrong. Next is question number 195. We are moving to cost budget alerts. A team wants to understand how an Azure AI workload has accumulated costs so far this month, and also receive warning if actual or forecasted spending approaches the monthly budget. Which combination best provides both capabilities? Option A. Use cost analysis for historical spend investigation and configure a cost management budget with actual or forecasted alert thresholds. Option B. Use only a resource lock. Option C. Use an application insights availability test. Option D. Use cost analysis alone and assume it automatically creates proactive budget notifications. The option that satisfies the complete requirement is option A. Use cost analysis for historical spend investigation and configure a cost management budget with actual or forecasted alert thresholds. The requirement to solution match is cost analysis explains accumulated spending and trends, while budgets can notify stakeholders when actual or forecasted cost crosses configured percentages of the budget. The incorrect choices are plausible, but unsuitable because B. Resource locks do not analyze or alert on spending. C. Availability tests monitor endpoint reachability. D. Cost analysis alone does not create the requested budget threshold notification. Watch for this clue in similar questions. Use cost analysis to understand spend and budgets to create proactive actual or forecasted cost alerts. Now tackle question number 196. Scenario. A platform team is reviewing identity, networking, moderation, alerting, and diagnostic export controls. Match each control to the operational problem it most directly addresses. Use each destination exactly once. The left side candidates are: left item 1, dynamic threshold metric alert; left item 2, workload identity federation; left item 3, diagnostic setting log categories; left item 4, private endpoint with private DNS; left item 5, per category content thresholds. The right side descriptions are: definition A, restrict exported telemetry to the selected log types required for troubleshooting. Definition B, detect deviations from a learn metric baseline instead of one fixed threshold. Definition C, authenticate CI/CD by short-lived federated token exchange instead of a stored Azure secret. Definition D, tune harmful content blocking independently for different harm categories. Definition E, resolve a supported Azure service to its private endpoint address from the virtual network. Here are the pairings after elimination. The defining role of dynamic threshold metric alert points to detect deviations from a learn metric baseline instead of one fixed threshold. The defining role of workload identity federation points to authenticate CI/CD by short-lived federated token exchange instead of a stored Azure secret. The defining role of diagnostic setting log categories points to restrict exported telemetry to the selected log types required for troubleshooting. The defining role of private endpoint with private DNS points to resolve a supported Azure service to its private endpoint address from the virtual network. The defining role of per category content thresholds points to tune harmful content blocking independently for different harm categories. Each control addresses a separate operational layer: adaptive anomaly alerting, secretless workload authentication, telemetry export selection, private DNS routing, and category-specific content moderation. Remember this decision rule. Keep authentication, networking, moderation, alerting, and telemetry routing controls conceptually separate. Each solves a different operational problem. For question number 197, separate the requirement from the distractors. Background. Fabricum is hardening the deployment process for an internal AI platform. Current environment. GitHub Actions currently authenticates with a stored Microsoft intra-application secret. Business requirements. No long-lived Azure credential may remain in the CI/CD platform. Technical requirements. GitHub should present an OIDC identity that Microsoft Intra ID validates against configured federation claims. Which change satisfies the requirement? Eliminate every option that violates even one requirement. Consider option A. Configure workload identity federation and remove the stored client secret from the workflow. Consider option B. Keep the client secret and rotate it more frequently. Consider option C. Rename the secret to make it less obvious. Consider option D. Grant anonymous deployment access. The correct choice is option A. Configure workload identity federation and remove the stored client secret from the workflow. This option satisfies the complete requirement because GitHub Actions can present an OIDC token that Microsoft Intra ID validates against a federated identity credential. Azure Access is obtained through short-lived token exchange without storing a long-lived application secret. Now eliminate the distractors. B. Rotation still leaves a persistent secret in the pipeline. C. Renaming a secret does not reduce credential exposure. D. Azure deployment remains an authenticated operation. Exam strategy. Federation is the preferred pattern when CI/CD must authenticate to Azure without storing long-lived application credentials. You have completed Set 5 of the AI-200 Microsoft Certified Azure AI Cloud Developer Associate Practice Question Series. How did you score? Share your result in the comments. Work through all the sets to build broader exam readiness and cover more practice questions. Please like this video, subscribe to Tech with Koushik, and enable notifications for more certification exam preparation content. Thank you for watching, and I will see you in another practice set.